All right, hello and welcome. This is going to be the homework help video for those last 4 problems on the Trig word problems homework that was given out on Monday. Let's go ahead and get started. Question 11. An object hangs from a spring in a stable equilibrium position. The spring is pulled 3 feet downward and the object begins to oscillate, making one complete oscillation every 4 seconds. Let me just underline my numbers as I go here. What is an equation for the motion of this object? At what 2 times within 1 cycle is the spring 2 feet below the equilibrium position? In this unit, we're just going to say if we can just find 1 time, then I'm happy. Use these values to find the next 2 times. Let's just skip that last part. I think if we can just do this, then that'll be good for this unit. Our next unit will be dealing with this. This requires a better understanding of inverse trig. So yeah, if you're watching the video, you just got permission to skip that last piece of this question. All right, let's get a little graph going. We'll say, so it starts 3 feet down. So I'll make this a minimum at 3. It's released and completes a full oscillation after 4 seconds, meaning that at 2 seconds, we're probably at our peak of +3. All right, so I need to write an equation for this graph here. It's going to keep going up and down. This will hit another max at 4, hit another min at 8, and so on. It's easy to see that the amplitude of this is 3. The midline is right there at 0 and stretches up to 3, so I'm going to use a 3. Now I have to decide if I want to use sine or cosine. Either would work here. I know it's crossing the midpoint probably at 1 second and then at 3 seconds. So I could do sine and then just shift it 1, but I also know where the peak is. I could do cosine and shift it 2. I guess I'll do sine. You did cosine, that's all right. The k value is 0. The h value, I'm going to do it inside a set of parentheses. I'm shifting this 1 unit to the right of where sine normally crosses our x equals 0 line. So to shift it 1 unit right, I have to subtract 1. It's always kind of the opposite of what you think. So last thing is my b value. I know that the period is equal to 2 pi divided by b. I know the period of this function is 4 seconds. So 4 equals 2 pi over b. In equations like this, I can swap those there to get b equals 2 pi over 4. Divide the top and the bottom by 2. And I'll get b equals pi over 2. So pi over 2 right here. And no k value, the midline is at 0. This hasn't been shifted up or down at all. All right, so that's a good equation for what we wanted. Let's take a look at number 12 now. A particle travels along the x-axis to the position s of t equals 7 sine of 4t, where t is in seconds and s is the x-coordinate of the particle. What is the x-coordinate of the particle at time t equals 7.1 seconds? So just remember that we forgot to actually answer this second part of this equation. We'll come back in just a second. 1 time when the spring is 2 feet below the equilibrium position. So to solve for that, that 2 feet below is going to be a y equals -2. I'm going to plug a -2 in for y. -2 equals 3 sine pi over 2 x minus 1. And we just have to do inverse operations until x is by itself. So we can divide both sides by 3. Get -2/3 equals sine of this whole thing. To get rid of the sine, we can do an inverse sine. So sine to the power of -1 of negative 2/3. You get that by just doing second sine on your calculator. So second sine negative 2/3. My calculator is in radian mode, which is good. It gives me the answer of negative 0.7297 radians is the unit for that. Equals pi over 2 x minus 1. Divide both sides by pi over 2. When I do this in the calculator, I'm going to divide my previous answer, but I'm going to keep the pi over 2 in its own set of parentheses. So that doesn't divide by pi and then divide by 2. It divides by the quantity pi over 2. I'll get negative 0.4646 equals x minus 1. Add 1, add 1. And so I know for certain at 0.53 seconds, it will be 2 feet below the equilibrium position. Let's look back up at our diagram. That makes sense. Between 0 and 1, so right about there, it hits -2. But in our next unit, we're going to be able to solve for all of these times where it hits -2. So that'll be a cool trick. All right. So sorry I forgot to do that. On to question 2. This one just asks us to plug in 7.4 for t and then solve for its x position. So I'll show that with my on-screen calculator. Let me pull that up. To calculate this, I'll just plug it in. Make sure I'm in radian mode. All of these problems have been in radian mode. We can just assume that this one is as well. I don't know if it exactly said it, but it is. So 7.4. So 7 sine of 4 times 7.4. Its x position is going to be -6.79. So for that one, -6.79 x units. -6.79. What is the largest value? Well, we can get that just from the amplitude. So the largest value is just going to be 7. And the frequency, we know we've got a formula for frequency. It's on the previous page here. Frequency equals 1 over period. So we've got to do a couple calculations for that. First, to get the period, we have to do 2 pi divided by b. So 2 pi divided by 4, which equals pi over 2. And now to get frequency is 1 divided by pi over 2. Copy dot flop, this becomes a frequency of 2 over pi. All right, that's everything in question 12. 13, when you board a Ferris wheel, you're 1 foot off the ground. At the highest point, you're 99 feet off the ground. It takes 30 seconds for the ride to complete 1 full revolution. Write a trigonometric equation for the height above the ground at t seconds after the ride starts. Find at what 2 times within 1 cycle you're exactly 90 feet off the ground. Again, we're just giving you permission to just find 1 time when we're exactly 90 feet off the ground. Although you could find 2. You just have to add 1 period length to the first time that you find the second, but let's just not worry about that. Okay, so my midpoint, let's find that first. Midpoint is going to be 99 plus 1 divided by 2. That equals 50, hopefully for obvious reasons. Now to get the amplitude, I can just do my maximum minus the midpoint to get the have an amplitude of 49 feet. You can think of that as the spokes of this Ferris wheel being 49 feet long. So, and then the axle is 50 feet above the ground, so that's why it swings you down to 1 foot above the ground and then 99 feet above the ground. 30 seconds to complete one full revolution. So the period equals 30, which equals 2 pi over b. So b equals 2 pi over 30, which equals pi over 15. And when you board, you're at a minimum. So here's an idea. Let's just take cosine and we'll flip it so that instead of starting at a peak, it starts at a low point, giving us the final equation of y equals negative 49, that's our amplitude, cosine of pi over 15, x just doesn't need to be shifted. We got it to the right starting point by just flipping cosine. And then we need to shift it up 50 points, so plus 50 feet. All right, find at what time we would be exactly 90 feet off the ground. So I'm going to plug in 90 here. And I'm going to undo the operations one at a time. So that negative 49 is the most outside operation. So I'm going to do 90 divided by negative 49. Oh, actually the most outside operation is this plus 50. My bad. So 90 minus the 50. So we're starting over. Then I can go ahead and divide it by the negative 49. Then I can do the inverse cosine. So I do second cosine, second answer to import the previous number. Now I got to get rid of that pi over 15. So I could do that by multiplying it by 15 over pi. Here, parentheses aren't crucial because multiplying by 15 over pi and multiplying by 15 and dividing by pi is the same. So I don't technically need parentheses there. And I'll get that at 12 seconds, 12.06 seconds. I'm going to be 90 feet off the ground. If I want another time, well, how about 42.06? Because if it's making a full revolution every 30 seconds, I'll be back at that point after 30 seconds. All right, last question. High tide, the water level of a particular boat dock is 9 feet deep. At low tide, the water is 3 feet deep. On a certain day, the low tide occurs at 3 a.m. and high tide occurs at 9 a.m. Find the equation for the height of the tide at time t, where t is equal to 3, where t equals 3 is 3 a.m. What is the water level at 2 p.m.? Okay. So, start with the graph. What do we know? Low tide is 3. Water's only 3 feet deep. And that occurs at 3. High tide, it's 9 feet deep at 9 a.m. So 9, meaning it's halfway in between at 6. And if we then work backwards, it's going through half of a cycle, so a quarter of a cycle every 3 hours. So it should be at 6 at 0. So that we're going 6, 3, 6, 9, 6, 3, 6, 9. All right, we'll connect these to the curved line. So it looks like a sinusoidal graph, 12, 15, and so on. So at 2 p.m., that's the same as 14. So we're trying to find this value here. Okay. Amplitude is 3. Hopefully we can just see that from the graph. Midpoint is 6. Again, just from the graph. The period Well, it completed half of a cycle in 6 hours, so the period is 12 hours, which also makes sense with what I know about tides. 2 pi divided by the period equals b, so pi over 6 is our b value. And now for the shift, let's see, I can do a sinusoidal graph and flip it. And that's all I would need to do to get this graph here, because sine waves have a midpoint at 0. They go up, so if I flip it with a negative, it'll come down. So y equals negative, I forgot my amplitude, negative 3 sine pi over 6x, no vertical shift, the negative takes care of that, plus our midline of 6. All right, let's calculate for when it's going to be equal to 14, and we'll be done. Let's just do that and calculate. I'll just do it out loud since we've done this several times. So 14 minus 6 divided by 3, divided by negative 3, I meant. So 8 divided by negative 3. Inverse sine of that number. Inverse sine, it's not giving it to me. 1 second. 14 minus 6 divided by negative 3. Oh, 1 sec. Okay. Mistake in the setup here. 14 is an x value. Should have plugged it in here and not there. But I was getting an error message that kind of tipped me off to I was making a mistake. So what I was doing accidentally was I was calculating for when the height of the wave would be 14, and I got an error message, and that makes sense because, well, the depth will never be 14. It only gets to a maximum of 9. So, okay, we can learn a little bit from Mr. Olson's mistakes here. Okay, so negative 3 times the sine of pi over 6 times, in parentheses, 14, close parentheses, plus 6. So I've got the height will be the depth will be 3.4 feet at 2 p.m. Which, yeah, looks about right. Okay, and we're done. That is the end of this video.